This is Snap Measure 2.1. Created specifically to make measuring intuitive and easy in Blender. Let's start by adding a couple of objects to measure. The Snap Measure panel is found within the Tool tab in the End panel. You start the tool by pressing the Start Snapping button. I recommend binding this button to your own shortcut. When the tool is activated, you will get different highlighting. This is based on if you are hovering a vertex, an edge, or a face. The center of either a face or an edge is a yellow highlight with the appropriate symbol. You initiate measuring by clicking and dragging where you want to measure. You can restrict the axis by holding X, Y, or Z. You delete all measurements with the Delete All but delete individual measurements with the trash icon next to the measurement in the panel. If you want the lines to be easily identifiable, use automatic names and randomize color. This will assign the line index as the name that is visible in the viewport. You can also manually assign names and colors to each measurement line. Let's make another measurement and open the advanced settings for the measurements. Here we have various settings to control the measurement. You can offset both the measurement and the text with the offset sliders. In the general settings, you can change font size and how many decimals you want to be displayed. Now let's try the object transformation behavior of the add-on. There are two sliders, one for object mode and one for edit mode. In object mode, you can move the selected object toward the end point or start point of the line. The selection determines which direction the object or objects move. Select the object you wish to move, and use the slider or type in your desired distance. If you select both objects, then they move toward or away from the midpoint. I forgot to mention that it is also possible to change the appearance of the line endpoint arrows. There are 3 types of endpoints available. You can show and hide text and arrows, both individually for each measurement, and globally for all of them. If you expand the advanced settings for a line, you can set the endpoint or start point to not be dynamic. This will change the behavior of the set distance sliders in certain cases, as you will see. The edit mode slider moves selected geometry, edges, vertices, or faces along a defined line. It adjusts positions symmetrically or toward the line's start or end, depending on the selection and connectivity. Disconnected parts follow the start or end of the line based on their association. You can also create virtual snap points on the measurement. The value that you type in will be the distance from the measurement start point, and will always retain this distance from the start point. This virtual snap point can be used to take measurements from, or to snap objects, or mesh elements to. If you press Ctrl, Shift, and C during the modal operation, you will enable geometry snapping mode. You can then select and hover the object you want to move. Click on the part of the object you wish to move and drag to either a virtual snap point or another object and release the mouse. This behavior works for object mode, which will move the object. If you toggle to edit mode, the selected mesh will then be moved to the desired location. Let's add a cylinder and try the slider behaviors on circular objects. We use the geometry snapping mode to move the cylinder to the midpoint of a face. If we draw a measurement on the diameter of the object or mesh, if we tick circular selection, we will be able to change the diameter with the sliders. With the tick activated, we can now scale the entire object as a cylinder. This would be the same behavior as if we were using the local transform orientation of the object and restricting the scaling in the appropriate axis, to only decrease the diameter and not the length of the object. We can use the measurements to move objects, or part of objects with respect to another. This creates a powerful workflow when creating parts for 3D printing. If we use this behavior on booleans, we can work non-destructively and easily modify our objects. The best way to work non-destructively is to measure on the booleans themselves. If a mesh has measurements and is modified, this will change the indices of the mesh, thus corrupting the measurements. If we want to measure a boolean which is party hidden, we select the boolean and enter edit mode. Isolate the boolean and initiate a measurement. Without releasing the mouse, you can then exit isolation mode and use axis restriction to target where the line should end. Since we are using the boolean as the active object, this will prioritize snapping to the boolean instead of the parent object, even though they have overlapping parts. So to prioritize which object you want to snap to if there are overlapping parts, then you have to make that as the active selection. Since both parts of the measurement is connected to the same object, you need to disable dynamic for the endpoint of the measurement, to avoid scaling the object. If you uncheck dynamic for the endpoint, then you can make a selection and move it with the distance slider. If we would apply the Boolean, we can still use the circular scaling on a measurement drawn on the diameter. Select which part you want to be affected by the circular scaling behavior. Then use the slider to set the distance. The axis restriction works in any custom transform orientation as well. If we want to render the measurements, we can just press the render button in the panel. Since overlays are usually not able to render, we will have to do some compositing to add the measurements to the render. When the render button is pressed, the add-on will automatically create the necessary compositing nodes and create a render and adding the measurements. The add-on will fetch the current scale and units of the scene. This makes it work for both imperial and metric units.